Okay, so let's start with today's class. Good evening, everyone. So what we covered yesterday, we saw that so how a Python program runs on our system, right? We also saw this platform independency and portability topic yesterday. Portability, right? So we saw that Python is portable and platform independent both because of its bytecode, right? So we are going to discuss about the features of Python programming language today. So what all features we have? So the first feature we have is Python is simple, easy to learn, and then it is expressive language, right? So when I say Python is simple, easy to learn and expressive, so what exactly does it mean? So basically, if you will look at the Python code and if you compare the Python code with other, the code in other programming languages, then probably this difference will be quite evident to you. So for example, let's say if I'm going to write a Java code, so generally how do we write? We need to define a class, so some public class, and you'll write one class name. Then you're going to write public static void main. Okay. And then here you write int a is equal to 10, then the semicolon, int b is equal to 20, int c is equal to a plus b, and system dot out dot print ln. Now, you don't have to learn this Java code basically. Just I'm showing you that how a sample Java code looks like, just to add two numbers, right? So this is how you're gonna add two numbers. So probably there might be some syntactical changes or you have to make, but generally our Java code looks like this to add two numbers. Now the same program, if you would like to write in Python, so you will write here a is equal to 10, b is equal to 20, c is equal to a plus b, and print c. That's it. Okay. So you can see that how simple this code is, and less number of line, less number of keywords, and it is more expressive. You can understand that what exactly you are doing here, and you can see that you are assigning one value to a variable, then a second value you are taking and assigning it to a variable, then you are adding those two numbers, and then you are printing the result, right? Keywords are very simple. This is the reason you are going to learn it, and it also depends that how simple a particular programming language is. It also depends on the number of keywords you have in a programming language. So if I'll talk about Java, so there are around total there are around more than 50 plus keywords in Java, whereas if you will come to Python, so in Python you have around 30 to 30 plus keywords in the Python. Okay, so learning 50 plus keywords with compared to the learning 30 plus keyword, this learning curve will be faster in or steeper in Python, right? So this is how simple it is. And if you will talk about that, so Python has been included into 10 standard CBSE. So even the kids are also learning this Python. So you can imagine that how simple it is, and you will not face much problem if you'll have a proper guidance. So anyone can basically learn this. Okay. So it is very simple. Easy to learn means to say if you will compare the learning curve of Java with compared to Python. So learning curve in Python will be quite steeper. This is due to the number of reasons. Once it is dynamically typed programming language, when it is interpreted programming language, these all are also the feature and one of the reason why it is learning Python is faster. So we will see that, and then you don't have to mug up a lot of technical keywords and all. You have very less number of keywords here, and once you know that, so you can say at least 30 to 40% of Python, if you will learn all these 30 plus keywords. Okay. So learning it will be very easy, and even application, when it comes to application, so developing the application, you can do it fast in Python with compared to the other programming languages. Okay, so a normal person who is not from programming background will be having a lot of doubts here, why we are writing public, why we are writing class, why we are writing public static void main and all those things. So a lot of questions will be arised in one's mind, right? Whereas if you look at this program, it is quite easier to understand for anyone. Anyone who knows a little bit of algebra will be able to understand this code, right? Okay, so this is it. And expressive means to say, you can see here we are using more keywords, and it is less expressive. Less expressive means to say, like you can say that if I want to print, just print the value of C. So why I'm writing system.out.println, but you can see here that you want to print, so you just write print statement. So it is more expressive compared to this language, right? So this is it about this feature. Next we have the next feature we have is Python is, we have seen Python is portable and platform independent both. So I should write platform independent and portable both. So when I say Python is platform independent and portable, so remember one thing, yesterday we have discussed this point already, that whenever we talk about platform independency, so whenever you can move the bytecode from one platform to another, okay, that particular programming language is said to be platform independent. And if you can move the source code from one platform to another, then that programming language is called portable language. So the example of portable language is what? The example of portable language is C, is Java, is Python, right? Or you can say C++, right? This is also a portable language. But when it comes to platform independent, so Python, Java, they all are platform independent. Okay, they are not. So C is not platform independent. C is only portable. Clear, everyone? Is it clear? Any question? Okay, fine. So the next point we have, next feature we have here in Python is Python is dynamically typed programming language. What do you mean by dynamically typed programming language? So basically we have a programming language called statically typed. So let's understand what is statically typed programming language. So what all programming languages are statically typed? So the statically typed programming languages are Java, or you can say C or C++ or C sharp. So C++, they all are statically typed programming language. Whenever I say statically typed programming language, so one thing you need to understand that you have to mention the data type of the variable which you are taking. Okay, without mentioning the data type, it will not be it will be giving you the error. So for example, if you see this Java code, I have mentioned the data type here that I'm going to take the integer data type here also integer, here also integer. If you will not mention this data type, it will give you the error. Why? Because in statically typed programming language, memory allocation happens for the variables. Memory allocation happens at compile time. These all are compile time language, right? So memory allocation happens at the compile time. Okay, for whatever variables or data type you'll be taking, the memory will be allocated when you will compile that code. Whereas in the case of dynamically typed programming language, so we have Python, or we have Python, which is dynamically typed. We have R also, which is dynamically typed. Okay, so these programming languages are dynamically typed. So the memory allocation for them happens at the runtime. At runtime, and you also don't have to specify the data type. Okay. For example, you can see in this code, I'm not specifying the data type for any variable. Okay. So at runtime, it will check that what value you are allocating to this variable, and based on that, the data type for this variable will be allocated. Clear, everyone? This is the reason, for example, let's say when at runtime, it will check whether actually you don't have that data type concept here in the Python. Data type means to say, for example, you don't have integer data type, or you don't have long data type, or you don't have short data type. Means these data types you don't have to mention explicitly. Everything in the case of number, like whole number, everything is considered to be integer. Okay, if you will take a smaller value, then a smaller amount of memory will be allocated. And if you take a larger value, then a long data type, it will be integer, but large memory will be allocated. Large amount of memory will be allocated. For example, let's say if I'm taking a is equal to 10, right? So a is equal to 10. This is a small value, right? 10 is very small number, right? So if you want to check that what amount of memory is allocated for this 10, so you can simply go ahead and write print sys dot get size of a. Okay, now if you will run this, you will get that 28 bytes of memory is allocated for a. Now let's say I will take another number, b is equal to quite a big number. This is a big number. Now I will just check the same thing here of b. Now if I'll see, it is 72 bytes of memory is allocated for this. So how it has allocated 72 byte of memory? Here, if you will check the type of a, let's say if I'm checking the type of a, type is a function which returns you the data type for the value associated with it. And if I check the type of b, both are integer type. They are not long type or short type. Both are integer type. So first of all, you need to understand that there is no concept of long and short compared to the other programming languages. Like in Java and C, you have long and short data type. But in Python, you don't have the long and short data type. You have only integers. So any whole number will be considered to be an integer. And why we have these different data types in other programming languages? Why? Because if you will take a large value, then automatically that value will be taken. Like, you have to take this variable as a long data type in the other programming languages. But in Python, you don't have to specify the data type. Every value will be considered as an int. And this long and short depends on the memory it is taking. So memory here, it is getting allocated at runtime. So there is no requirement of long and short data type in Python. Similarly, we don't have char data type in the case of string. Similarly, we don't have the double data type in the case of float. Okay, so there is no concept of char, long, short, or double data type in Python. Clear? Everything, every whole number will be considered as int. Every decimal value, a value with a decimal point will be considered as float, and every value which is in the quotation will be considered as a string. Is that clear, everyone? Fine. Any question? Okay, great. So this is about, so when we say Python is dynamically typed programming language, it means we don't have to specify the data type in the code. That is one thing. And second thing, the memory allocation in this case will happen at the runtime, not at the compile time. Okay. Now, the next point we have here is, so Python is freeware and open source. When I say freeware and open source, what do you mean by this? So freeware means it is free of cost. So to use Python, you don't have to purchase the license. Okay, you don't have to spend money. That is called freeware. Now, what is open source? So open source is basically we talk about source code basically. When we say open source, we talk about source code. So if source code of Python is available to you, then that is called the open source. So if anything, let's say if any application is there, for that application, if you can download the source code freely at no cost, then that application is said to be open source. Okay, and freeware means if you are downloading any application and using it without paying any single rupee, then that is called freeware. For example, if I will talk about Python, so what you downloaded python.exe at free of cost, right? And you have installed it and you are using it, correct? So that is what, that is a freeware, correct? Now, can I download the source code of Python? Source code of Python means the code, the code written to develop Python. Can we download that? Can we download that? There are different implementation of Python, Arjun. So we will come to that. We have different flavors: C Python, Java Python. Initially, it was written in C, but slowly we have the different implementation. C Python, we have Java Python, we have Ruby Python, then Anaconda Python, Stackless Python. There are different implementation. Okay, so we'll come to that later. Okay, so source code of Python, when we are saying, can we download the source code of Python? From where we can download? So see, there is an official website of Python. That website is called python.org. Okay, this is the official website of Python, and here you can go and download the the main Python. You can say this is C Python. Okay, and in this download section, when you will click on this Python 3.8.3, this will download the .exe file in Windows and .dmg file in the Mac. Okay, but when you will click on this source code, it will guide you to this page. You can go and you can download the source code of any release. Okay, whether it is 2.7 or 2.x or 3.x, you can go there and you can download this. Okay, you can come to this and you can download this. This is, I will keep it on desktop. See this. Okay, so I think it is already downloaded. Let me check on the desktop. Yes, this is the file which is already downloaded. Okay, no, not this one. Sorry. It is my folder. It's my data science. Let me download this. Okay, so this is the folder which has been extracted, and you can see this is the source code, the code in which, so for example, you have math module, you have the other module, so that you will find here in the module, you can come and you can see that there are different math module or whatever modules which has been used in Python. This is ABC module. Okay, so everything is available here in this source code. Okay, so this is the source code which is written initially into C, and you can download it at free of cost, and you can make the changes into this source code according to your requirement. Correct. So let's say if you want to develop your own Python with your with a fixed set of functionalities, you can go and download. You don't have to develop this Python from very scratch. You can simply go ahead and download this source code, and you can make the changes wherever you want to make the changes, and you can develop your own version of Python. What is mean by source code? What is the difference between downloading source code and the only Python? See, source code is basically any code which you write that is called the source code. Let's say I have written this program. This is also called the source code. Servering. Okay, this is also called the source code. This is Python source code. This is Java source code. Any program which you write, that is called the source code. Okay, so Python is also an application, right? And it has been developed using some programming language. It has been developed using C. So this is called the Python source code. Okay, so this Python application has been developed using C, and the written code in C, that is called the source code of Python. Clear? Clear, Sarvari? Is it clear? Okay. Next, any question? Someone raise the hand. Any question? Any other question? Anyone having any question? Sumit, do you have any question? Okay. Okay. So let's move to next. So what we have seen, that we are able to download the source code of Python, as well as if you want to use Python, you can simply go ahead and download. You have downloaded Anaconda, right? That is the implementation of Python. So have you paid something for that? No. Whereas if I will talk about Windows, let's say if I talk about Windows, Okay, so Windows, when you go ahead and want to install Windows on your operating system, you pay some money, right, to purchase the license, and then they give you the .exe file. Remember, .exe file is not the source code, that is executable file, right? So for installing Windows.exe, you give some money, so that is not freeware, correct? It is not freeware. Similarly, can you get the source code of Windows? The code written for Windows, can you get that code? No, you cannot get that code. So it is not open source. Clear? Fine. So similarly, if I'll talk about Java. So see, Java individual edition is free, but enterprise edition is not free. Okay, enterprise edition is not free, so it is again not freeware. And can you get the source code of Java? No. So again, this is also not freeware and not open source. You cannot get the source code of Java. That is the proprietorship of now Oracle. Previously it was for Sun Microsystem. Correct? Fine, everyone. Is it clear? Any question? Next, Python is we say extensible and embedded both. Now, when I say Python is extensible and embedded both, what do you mean by this statement? So basically, when we talk about extensibility, it means if we can import the code from other programming languages to Python. Okay, so other programming languages to Python, correct? If we can import the code from other programming languages to Python, then that particular, or any particular programming language, then that particular programming language is called extensible. And embedded means what? If we can export Python code to other programming languages, then we say that is embedded. Why Python has free source code when compared to Java and others? Because it was developed like that. It is not a proprietorship of a particular person, and Java was the proprietorship of, initially it was developed by Sun Microsystems, so they made it closed, like they didn't make it open source. But Python, it depends on the developer. Tomorrow you can develop one application, and it is completely your call whether you want to make it open source or freeware. Okay, there are a lot of freeware applications available on Google Store. You can go ahead and download those applications and you can start using them, right? You don't have to pay a single rupee for that, correct? But at the same time, are they open source? No. For example, can you get the source code of PUBG? I don't know whether you can get it or not, but if you cannot get it, then it is not open source. But you can download and install it, and you can play PUBG games. So that is freeware. So there are a lot of applications which are freeware but not open source, and it completely depends on the developer or the group of team who are developing that. Okay, so whether you want to make it open source or freeware. What is the advantage of having it open source? The advantage of having the open source is multiple people can contribute to your project. Whereas to develop that project, you have to hire a team and you have to give the payment. Whereas if you will see Python, the way it has developed, you don't have lots of modules which are not developed by their core team. They has been developed by the people like us. When I'm working on Python, I feel that there are few features which are not available in Python. I will go ahead, download the source code, make the changes, upload it in the Python community, and I will suggest them to make those changes available in the next version. So this has made the Python to evolve over time. Okay. And evolve means strongly evolve over time. Okay. Okay, so now we are talking about extensibility properties and embedded property. So extensible property means to say when you can move the other programming languages, or you can use the code written in other programming languages to Python, then we say that particular programming language Python is extensible. Similarly, if we can use the code written in Python to other programming languages, we say it is embedded. Okay. Now, how you can do that? For example, if I will take, so can we do that? Yes, we have Numpy. Numpy is written in C. Okay, this is a module in Python. It is written in C. We are using it in Python. So you can write the code in C, and you can import that particular code in C after compiling it, and you can use that. So that is the extensible property. Similarly, you can develop one application in Python, or you can write one function in Python, and you can use that Python code into some other programming languages in C or in Java. You can do that. Okay. So these all are the different properties of Python. I hope this is clear. Let me know if you have any question in this. Any question here? We have already discussed yesterday that Python is compiled and interpreted language both. So we have discussed all the properties. Let me know if you have any question. Otherwise, we will move to the next topic, which is memory management in Python. No question, right? So next we have memory management in Python. Okay. Do it require big data to fed manually, or we can import with Excel? See, you can import big data also, you can import Excel data also. So there are different modules for that. There are different ways to import that and do the processing in that. We will be learning about them in upcoming classes. Okay, fine. So I'm getting your, in place of your name, I'm getting the number. Okay, so can you please change your name? There is a rename button in the participant side, so you can go ahead and Anil. Okay, Anil. Why? Because it is very difficult to. Okay, anyway. So next we have memory management in Python. Now, how this memory management in Python happens? So first thing you need to understand that memory management in Python is automatic. Okay, you as a user are not going to interfere into the memory management in Python. Okay, it is completely automatic. So what is basically memory management? So main two terms are there: allocation and deallocation. These all are the two things. So some value will be allocated, some memory will be allocated to a value, or some memory will be deallocated to for a value. Okay, so this allocation and deallocation completely is automatic. You are not going to interfere into that. And one more thing you need to understand, that in Python everything is an object. Everything is an object. Okay, now when we say everything is an object, so we know one thing, that object will always get stored in the heap area. Now what is this heap area? Heap area is a section of the memory which gets created when you run any Python program. Okay, we will see that with a few images and with a program also, so probably this part will be clear. But as of now, few things you need to remember. In Python, memory management is completely automatic. Next, when we say memory management, what does it mean? It means there are two terms: allocation and deallocation. Allocation and deallocation of what? Allocation and deallocation of the object. Then what all objects we have? So in Python, everything is an object. Now, where this allocation and deallocation happens, these all things happens in the heap area. And who is responsible to do this memory allocation? The person who is responsible to do this is PVM. This stands for Python Virtual Machine, which we saw yesterday in our image. Okay, Python Virtual Machine, PVM. It is responsible to do this memory management in Python. Okay, you are not going to interfere in the memory management at all. Now let's see how this memory management happened. First of all, we know one thing from yesterday's discussion, that which is the first application which gets loaded into the RAM? Which is the first application which gets loaded into the RAM? OS. So if you don't have OS, can you run a Python program? Let's say if I don't have this Mac OS or Windows OS on our system, can we run any application or any Python program on our system? No, right? We cannot run any Python program on our system. So if you want to run, let's say we have a Python file f1.py. Can we run this f1.py without OS? No, we need one OS on our system. Okay, why? Because this f1.py needs some memory to work upon. Okay, some memory will be allocated for this f1.py in the RAM, right? and that memory allocation will be happening by what? By OS. Operating system will be responsible to do that. And also, after allocating the memory, there will be a continuous interaction with the CPU. So, what duration of CPU this f1.py will be able to access, that will also be decided by the OS, because your other programs are also running in the background, right? So that all things will be decided. Basically, in other words, we can say the resource allocation will be done by the OS. So if you will see this image, if you will see this image, in this image you can see that there is an OS which is getting loaded into the RAM first, and then if you are running any Python program, that Python program will be loaded into the RAM. For example, you can see in this image, OS is the first application which is running into the RAM. After that, you have opened a different application, Pent and F1. Focus on the left hand side. Leave the right hand side, I will explain it later. Focus on the left hand side. OS is the first application, then you have Pent, and then you have f1.py, correct? So f1.py is the Pent application, Python application, and Pent is one more application which is running into your system. Now let's come back to this previous image. So this is after, once the program is loaded, but there are few terms inside this Python. We have discussed it here. PVM, object specific allocator, and raw memory allocator. These are the three memory management tool in Python. Three memory management tool in Python. Okay, so what are memory management tools we have? First, at very deep level, we have PVM. Okay, which is very important. On top of that, we have object specific allocator. And then we have raw memory allocator. Okay, raw memory allocator. Now, so very, you can say at quantum level, if you will see, PVM is very important. Then after that, we have object specific allocator, and then we have raw memory allocator. But we'll start our discussion from this side, raw memory to specific and then PVM. So first of all, what is raw memory allocator? So PVM is responsible to allocate the memory to the objects defined in your program. Remember, PVM is responsible to allocate the memory used in your program. Allocate the memory to the objects used in your program. For example, 10 or this big number, right? So the memory allocated to these objects will be decided by PVM. Okay, and object specific allocator. But at the very superficial level, your program also needs some memory into the RAM, right? This f1.py needs 10 KB of memory, or 1 KB of memory, or 10 MB of memory, or 10 GB of memory. Will be decided by what? That will be decided by raw memory allocator. Okay, let's say if you have started one program, initially 10 KB of memory is allocated to f1.py, but after running, when you have started creating more and more objects, your program may need some extra memory, isn't it? Over the time, some extra memory will be required. So some request has to be sent to OS, right? That we need extra memory, then only memory will be allocated to this Python program. So that request is sent by the raw memory allocator. Okay. So if you need extra memory, raw memory allocator comes into the picture, and it will be responsible to allocate the extra memory to your whole Python program. Okay. Clear? So if you are in the scarcity, so if you can learn here, it is the lowest level memory manager in Python, interacts with the memory manager of OS, and make sure that enough space available in private heap to store Python related data. So if this raw memory allocator is not there, you will not be able to communicate with the OS directly. Okay. So there is a mediator between PVM or your Python program and operating system. Is that clear, everyone? Is it clear? Raw memory allocator? Hello. Okay. So there are two memory allocations, the two ways the memory allocation is happening. One is what? So there are two levels of memory allocation. One is this top level and another is at this bottom level. Okay. So when I say at the top level, let's say this is the Python program. This is f1.py. Correct. This f1.py needs some memory. So this you can say that it is the application level. Application, how much memory is required by your application, that will be decided by raw memory allocator. But inside the application, let's say you have written some program, right? This is the code line 1. You have 1, then code 2, then you have code 3. Correct. So this is the code you have written. Now at the code level, again memory allocation is required. So at the code level, which tool is responsible in that? PVM and object specific allocator. Correct. So these all are the two tools which are required at the quantum level. Whereas at the superficial level, the tool which will be useful will be raw memory allocator. Clear? Fine, everyone. So now let's come to this. Next we have this. Okay. Now once this is handled, so let's say if your application needs extra memory, a request will be sent by the raw memory allocator to OS, and then OS will respond with the extra amount of memory to your Python program. Okay, in the RAM, some extra amount of memory will be required. Now inside the program, so there is a PVM. PVM has object specific allocator. Now what is this object specific allocator? Name itself says that we know that in Python everything is an object. In Python everything is an object. So for every object you will have one object specific allocator. What all objects we have? So there are different objects. I will write few names here. So there is integer object, there is float object, there is complex object. They are data type also, by the way, or data structure also in Python we say. Int, float, complex, then we have boolean, then we have string, then we have none object, then we have list object, tuple, set, Trojan set, then we have dictionary, then we have range. Okay, what else? Bytes, byte array. We have functions. This is also an object. Generator is also an object. Then we have filter object. We have map object. We have reversed object. Then we have sorted object. Okay, we have reduced, no, not reduced object. So there are different kind of object, correct? So these all are the different kind of objects which will be created, and for every object there will be a different object specific allocator into a Python. So whatever object you have seen here, so there will be a different object specific allocator in Python. Okay, so for every object type there will be an object specific allocator in Python. Clear? So why? The question is why? Why int object cannot allocate the memory for float? So going forward, we will see the memory management policy followed by integer is completely different from float or any other object. So different object follows different memory management policies. Okay. Due to this reason, we have for different object, we have different object specific allocator. Is that clear, everyone? Okay. Okay. Now, when we come to PVM, so PVM is Python virtual machine and it has control over the heap area. Heap area is responsible to store the object. All the objects in Python get stored into the heap area, and PVM is responsible to manage the heap area. Okay, so there is it will see that if there is any object which is not having any reference, so automatic garbage collection will happen for that object. Basically, it manages the memory into the heap area, and this is the very granular level of memory management tool in Python. It is the very lowest level of memory management tool in Python. Okay, and you don't have, you can see here last line, user does not have any control over heap area. You don't have any control over heap area. You cannot control heap area. Only PVM is responsible to manage the heap area. And out of all these things, the heap area is the most important part. Okay, heap area is the most important part. Clear? Now let's understand this code. First of all, you have loaded one code. When you load this code gets this memory gets splitted into different parts. One is you will get code area, next you will get variable area, next you will get heap area, and then stack area. This is free area, which is free in size, and if your heap area and stack area needs more memory, then this will start expanding into these directions, and when it will be colliding, then the next memory, extra memory request will be sent by the raw memory allocator to OS. Okay, if this free memory area will be exhausted, then extra memory request will be sent by the raw memory allocator to the OS, and then extra memory will again be allocated. Okay, now inside this, I will discuss about variable area and heap area. Code area is fixed in size. This code gets loaded in this, so this code is going to remain constant when you are running the application. So it will remain constant, right? So this, I'm not going to discuss much about code area because it is constant in size, and code will get loaded into it. Stack area is what? So stack area is responsible to manage the order in which functions will be executed in Python. So when we will go to function, I will discuss about this stack area later. But right now, the most important part here is variable area and heap area. I will discuss with respect to this program. So now let's draw this image here. Yeah. So we have this. Now you can see this is the code. A is equal to 10, B is equal to 20, C is equal to A plus B. This is the heap area and this is the variable area. Focus on these two parts. Now, whenever you start executing the code, Python is sequential execution. It will start executing the code from the very first line, and it will keep on executing the code line by line. Okay, until and unless there is some control in that. For example, if or loop or some function. So it will continue till then. Okay. So once we will come across if, loop and all, then it will control the code. But as of now, it is the normal execution. So it will start executing from the very first line. So when you will start executing from here, so what will happen? See, this is the expression. In the case of expression, the value on the right hand side first will be allocated. The memory will be allocated for this because Python has to check what is the data type of this value. Accordingly, data type for this will be allocated, right? So at the interpretation stage, this 10 will be allocated some memory into the heap area, right? This is 10 is an int object. So this will be saved in the heap area 10. And let's say the ID for that is X. Okay. So basically with this, you are saying A is pointing to X. So A will be a variable which will be created into variable area and it will be pointing to X. Clear? So this first line is done. Next, come to the second line. It will come again. It will check first on the right hand side. The right hand side 20 is the object. It will be saved into the heap area, and the ID allocated for this will be, let's say, Y. So again, B is a variable. B will be stored in the variable area, and B will be pointing to Y. Now let's come to C. When it will come to third line, so it will first check whether A is available in the variable area. Yes, it is available. What is the ID associated with it? X. X will be replaced here in place of A. Next, it will come to B. B is available. Yes, B is available. What is the ID? Y. Y will be replaced here in place of B. Now the value at X and Y will be faced, which is 10 and 20, and then a new object 30 will be created, right? 30 value will be created, which is a new object. So this 30 will be created in the heap area, and the memory allocated for this will be Z. Okay, let's say Z. So C will be now pointing to Z. Clear? Now come to the last line. So this is a function call. In the function call, whatever you have inside the bracket first, it will be executed, this expression. So C is a variable. Check whether C is available. Yes. What is the ID? Z. So G will get replaced here. And then the value associated with Z is 30. So 30 will get printed on the screen, output screen. So 30 is the output. And then this print will return none. This none will also be created into the heap area. What is this none? I will discuss it in the function chapter. Okay. Not now. But this is how a generally memory allocation or deallocation happens internally. Heap area, inside the heap area, all the objects will get stored. All the variables, global variables will get stored in the variable area. Clear, everyone? Is this clear? How a Python program is running? Any question? No. Any question? Why it needs X and see X and Y are the ID. X and Y are the memory ID where see whenever you are saying, let's say what I said, let's say if you are printing C. So from this print C, the control will go to variable area. It will check whether C variable is available or not. If C variable is available and if you will not have that reference, so how you will fetch the value from the heap area? So you need to have one reference, you need to have one ID, memory ID, at which ID this value is saved, right? So if you will not have that ID, how you will be able to know that where this thought is saved? And remember, this ID is very important. If you will lose this ID, you cannot fetch this value, because this heap is like an ocean. In that ocean, you just can go and you cannot randomly go and pick the value from that ocean. You have to have the reference that at which position exactly you have to go. Okay. PVM controls only heap area or only one type of object. PVM controls heap area only. For controlling the object, you have different arrangement. Object specific allocator for how much memory and how the memory allocation will be happening for the different object. That will be done by the object specific allocator. PVM is responsible to manage the heap area. Okay. Clear, everyone? So now let's see this with the code. I will execute this. You need to install Thorny editor, okay, for initial few classes, or it may be useful even for you also. If you're not, if you're using it in the normal code also, you will come to know a lot of internal part of the Python if you will use this editor. Initially, when you will install this Thorny editor, it will look like this. You can go to view, and in view you can click on heap and variables. These two area will be shown here. You can go and check every time this heap and variable, the values, the way I have explained, similarly it will be created here. So let's say I'm going to, if I run this code, see, directly running the code will be creating this ID and variable, everything in this heap and variable area. So we'll not be able to analyze this. So for analysis, we will be debugging this code manually here. So we are going to use this debugger, and then we have this key, step into, use this key and just observe that how this code is executing. Wherever this yellow line is coming or if this yellow bracket box is coming, it means we are going to execute that part. Currently we are into the first line, and in the first line, first right hand side part will be executed. So step into it, you will see this yellow is pointing to the right hand side. Okay. Yeah, you can check in the spider also. If it has the same panel, then you can check it there also. But I prefer this one. I use this one, so you can check this one. Okay. We have this 10. So this 10 will be created in the heap area. You have this 10, and the ID allocated for this is 1C40. This is the random memory allocation. Any ID will be allocated. Okay. So for 10, the memory allocated is 1C40. Now, this A will be allocated some memory in the variable area, and A will be pointing to the same ID. You can check here. Here A is pointing to the same ID, right? Clear? Everyone? You may install it right now, or you may install it later, but make sure that you install it and you use it to understand the program. Okay. So next we are running this second line of code. So in the second line of code, again it will do the same thing. Link is simple, thorny.org. thorny.org. Okay. Thorny.org, go there and download it from for Windows, Mac, or whatever. Now we are coming to this. We have next second line. So we are coming to this 20. So this first 20 will be allocated into the heap area, and then B will be pointing to the same ID, right? So 20 is allocated 1D80, and B will be pointing to the same ID in the variable area 1D80. Correct. Now come to the next line. You will see that on the right hand side, A is pointing. So it will look for A. What is the ID for A? It is 1C40. So this ID will be replaced here. You can see 1C40. Similarly for B, B is available, ID is 1D80, the two value will be fetched and then the value will be combined. The combination is 30 and one new memory is allocated into the heap area is 1EC0 for 30. So C will be pointing to 1EC0. Now if you will print C, so C here in the place of C, this ID will be replaced of C, which is 1EC0, and finally it will print the value in the output string, which you can see here, 30. Clear? Clear everyone? Here you can see none object. Why? Because print function returns none object, and that's how a Python program runs. And memory allocation happens automatically. You are not responsible to do the memory allocations at all. Clear everyone? Any question? Okay. So what you can do initially, you can use Thorny editor. The program which you are writing, even if you are writing the simple program or complex program, try to write it in Thorny editor. The reason is if you will be using it, this Thorny editor, lot of internal parts you will come to know, and you will come to know that how Python is behaving. Once you will come to know the internal part, really you can imagine the code. Okay, whenever you are going to do the operation, you will be able to do the imagination. Your imagination power will increase, and probably then that will improve the coding part in for you. Okay, so it all depends on you. You can use this editor or Jupyter Notebook, anything. Fine. Okay, so the next part we have is, so this is about memory allocation. We have seen that how memory allocation is happening. Next we have memory deallocation. When we say memory deallocation, this is also automatic in Python. Okay, and when we say automatic, so who is responsible? So there is a module called GC module that stands for garbage collection. Garbage collection module, which is available in Python. Okay, now this GC module in Python runs automatically. Okay, you don't have to call this GC module explicitly like you do it in Java, or this garbage collection you do it in other programming languages explicitly. In Python it is implicit. You don't have to call this GC module every now and then. What it does, so from time to time this GC module will run, and it will check that what all objects you have in the heap area which are having the reference count 0. As soon as the reference count for any object reaches to 0, that object will be automatically garbage collected. Clear? For example, if you will see this code, so see, if I will run this code, so you will see that A, B, C are all created here in the heap area, right? Why? Because 10, 20 and 30 are having at least one reference. For 10 there is one reference, for 20 there is one reference, for 30 also there is one reference. So automatic garbage collection is not happening. But let's say if you will delete the references, I will delete A. See, I'm not deleting any value. I'm not managing heap area. I'm managing variable area. I'm deleting the reference. I'm not deleting the object. You cannot manage heap area. Okay. I'm deleting A, this variable. So reference of 10 is deleted. Now, if I will run this code, you will see automatically this 10 will be removed from the heap area. So let's run this. You can see 10 is removed from the heap area, whereas only 20 and 30 are there. Correct? Fine. So as soon as the reference count for any object reaches to 0, okay, that object will be automatically garbage collected by the GC module. Clear, everyone? Is it clear? Any question? Okay. So this is it about this memory allocation and deallocation. Next, we have different flavors of a Python program. So the different flavors of a Python program we have is C Python, J Python, then PyPy, Ruby Python, and Anaconda Python. Now, what is this C Python is used for? So C Python is basically the C implementation of Python developed to run C application. Okay. So if you are using C Python, so which Python is C Python? The Python which you download from python.org, this is CPython. So this is the default Python which was developed initially. Okay, so this is CPython, and the Python which you download from here, that is CPython. For Anaconda Python, you have different website. For JPython, you have a different website. For PyPy, you have a different website. You can go and download the versions from those websites. Okay, for PyPy, I think there is pypy.org, or JPython, there is a jpython.org or python.org. You can go and download those implementation of Python from there. And for what purpose these different implementations are developed? So different purposes. For example, if you have any C application and if you have JVM installed on your system, you cannot run CPython. But if you have installed Python from this particular application, this particular website which downloads CPython, and if you want to run .exe file on PVM, you can run that. Okay. Similarly, if you want to run Java application on the PVM, so you have to install JPython implementation. If you want to run Ruby application on Python, then you have to Ruby application, then you have to install Ruby Python. Stackless Python is mainly developed to run the concurrent program. So you cannot run two Python program simultaneously. To counter that problem, we came up with Stackless Python, where you can achieve the concurrency. So you can run multiple Python applications in a single platform. And then Anaconda Python is mainly developed for dealing with the big data. For example, if you want to do some data analysis with the big data, probably CPython and JPython or other implementation of Python will not support. They will get stuck, whereas Anaconda Python will be able to handle the big amount of data automatically. Clear, everyone? So these all are the different implementations of Python. Let me know if you have any question till here. Okay, fine. So next we have the different components of a Python program. So this part we will cover in the next week. From this, we have two more topic: components of a Python program and data types. Okay. So what I want, do you guys have got any confirmation that on which all days we have the classes from next week, like in the next week, Monday to Friday, or it is alternate days? Okay. Okay. Okay, fine. Okay, so I think I forgot to check with Learnbay team. So probably that is going to be on alternate days, because I have other class also in next week in evening 8 to 10. So probably this is going to be alternate days. Okay, so you'll get to know whether it is Monday, Wednesday, or Friday, or Tuesday and Thursday. You'll get to know about that. We'll be using Anaconda Python Pranjal. Which tool is mainly used for developing codes in Python? Tool means to say, are you talking about the IDs? If you are talking about IDs for development side, we use PyCharm, but for data analysis side, we use this Anaconda Python only. Okay, Amrita. Pranjal, we are going to use Anaconda. Okay, not CPython. Okay. Yeah, so we will cover this next part. So start reading this one. Okay, complete this one, and next week, if we are meeting on Monday, so we will discuss the next two parts. So in two classes, this things will be covered. Okay. Numpy is a module. Yes, you can say it is a tool to handle arrays in Python. Okay, Amrita. Numpy is a tool to handle arrays in Python. You have a built-in array module that provides you the efficient storage but does not provide you the efficient operations on array. So for that reason, we have came up with Numpy module, which provides you the efficient storage and efficient operations also on array. Clear everyone? Any question? Any other question? Any other question you have? Um, okay. What is the URL of Python notes? That I have given in this. So I think yesterday I provided. You guys have probably downloaded this. You have joined the Google Classroom. So in that also this notes will be made available today. Just 1 minute. This is the link. Yes, Anil, coding in the most of the implementation, coding remains same. You are not going to, for example, in JPython, syntactically there will be not much difference. Code, the syntax remains same always. Okay. So syntax will in most of the cases it will remain same. There might be few small changes here and there, but not much differences. Fine. Okay. So I think let me know if you have any question. Otherwise, I'll end this session here. I'll not proceed further because we have discussed enough till here. So we will discuss these two topics in the next week. Let's see when we have the next class. So I think whether it is Monday or Tuesday, I don't know. I need to confirm on that. So in two class, this part, these two things will be covered. Okay. So we'll meet next week. Any other question? Okay. Fine then. So yes, no or Praveen. Yes, Praveen. You have any question? Praveen, do you have any question? Okay. Anyway, thank you everyone. Thanks for joining. So we'll meet next week and then we'll start from here again. Thank you. Good night.